In this video, we'll look at the topic of antiderivatives, and based on definition, the big F of x is an antiderivative of the small f if the derivative of the big F is actually the same as the small f. So I can actually present this statement in terms of a picture as follows. Please look at the current picture. I hope it clarifies your misunderstanding if you have. And the big F is on the left-hand side, you see. And if you differentiate the big F, you'll get the small f. And if you want to get from the small f to the big F, you can do a process called anti-differentiation, which is exactly the opposite process to the differentiation you are used to. And now the question usually is that, usually you are given a function small f, you need to find a big F, which is what we call the antiderivative here. And let's look at some examples. Now you're given a function small f of x, which is 7, and I would like to ask you to find the antiderivative of the small f. So we can easily make a good guess about that if you are very familiar with the differentiation rules. And please think about it yourself here. The derivative of certain function is the same as 7. And in case you are very comfortable with the basic differentiation rules already, I think that if I pick 7x here, the derivative is exactly 7, right? So it means that I can actually choose the 7x to be my big F. And it is an antiderivative of the small f7, right? And let's look at another example. Now I'm giving you a function 2x, and you need to find the antiderivative of the small f here. You need to make a good guess of certain function such that if you take derivative of it, it is equal to 2x. And I think for those of you who are familiar with the power rule, it is quite easy to guess that it is actually square. So I think I can just make the big F to be x squared. Then we find the derivative of it is gonna be 2x, which is the small f of x. And it means this answer must be correct, right? Because if we differentiate that, we get back the 2x, which is clear. So let's look at another example. You're given the function 3 times cosine of x plus 5. You need to make a good guess about the big F, which is the antiderivative of the small f. And once again, we have to make a good guess about that. And I think to get 5, I think 5x is a good choice because the derivative of 5x is exactly 5. And for 3 cosine x, for those of you who are familiar with the differentiation rules for the sine and cosine, you would notice that I can just choose it to be 3 times sine of x, right? If you choose 3 times sine of x there, I think it would be quite easy to see that the derivative of it is exactly the same as the right-hand side. It means that I can just write the antiderivative as 3 times sine x plus 5x, right? And let's look at another example. So now you're given a function x squared, and let's find an antiderivative of the x squared. And once again, you have to make a good guess. What function would you guess such that if you take derivative of it, you'll get the x squared? And if you are familiar with the power rule in differentiation, you would notice that we definitely need something like x cubed. But if you check it in your mind, x cubed derivative is the same as 3 times x squared, right? So there's a factor of 3 that is the difference between this function and the given function x squared. So what can we do about that? Please check in your mind. I mean, if I write the 3 as a division factor for the function x cubed, let's differentiate together. So 1 over 3 as a constant is there, and you differentiate x cubed to get 3x squared. So you see, in that case, 3 and 3 cancelled. It means the derivative of 1 over 3 times x cubed is going to be x squared, right? So it means I can make the f, which is an antiderivative of the small f of x, to be 1 over 3 times x cubed. And that's the answer to this problem. So please look at the note I give here. I'm claiming that there are actually infinitely many choices of antiderivatives for any given function f. And let me point you to a specific example and we can talk about that. For example, let's look at this simple case where the small f of x is the same as 2x. And you can easily see that I can easily choose the big F as one of the antiderivative to be x squared, right? So because now the big F, if you take derivative, is exactly 2x, so it is fine. And but if you think more carefully, there are actually so many other choices. How about I can choose big G of x to be x squared plus 1. And now you differentiate the big G of x, you get the derivative as 2x, right? Which is the same as the small f. So it means what? It means that the big G is actually another choice of antiderivative, right? So instead of looking at x squared plus 1, you can say maybe x squared plus 2, x squared minus 1, x squared plus 0.5. And the fact is that if you add or subtract any constant from x squared, because of the fact that you differentiate constant to get 0, the fact is that for all of this, all the antiderivative of the function 2x, right? Because adding or subtracting a constant from x squared does not change the derivative of the big G at all. So it means what? It means the following. It means that we just have to write the big F as x squared plus c, and c is any constant basically. You can choose any constant there randomly and you put it in, and still this big F of x squared plus c is still an antiderivative for the function 2x, right? And because there are so many choices of antiderivatives, and to condense our notation a little bit, we'll give a new notation here. Please look at the following. So now it is a totally new notation for you. I call it indefinite integral. Please look at my notation here. This one is called the indefinite integral of the functions f of x. By definition, it should contain all the possible choices of antiderivative of the given function f of x here. So let's do a simple example here. If you look at my previous example, you would see that if I put the function as 2x, now you need to list all possible choices of antiderivatives of 2x, and I think the answer is the same as x squared plus c, right? And c is any constant. So that's the best way to list all the general antiderivatives for any given function f of x here. And it's going to be a difficult exercise if I randomly give you some function small f of x here. Maybe it would be difficult to make such a guess, right? Because we don't have any specific techniques for now to do all of this calculation for the indefinite integral. What I did for this case, 2x becomes x squared plus c for the indefinite integral. Instead, I just make a guess, basically. I make the guess that x squared plus c, if you take derivative, is the same as 2x, right? Based on this fact, I actually make this guess, which is correct. But there are actually so many techniques to find indefinite integral in the case that if the function is more difficult. And we'll make a lot more videos to introduce that.